Suppose the Farm 1 and Farm 2 produces differentiated good, and the demand function of good 1 is this, which is produced by Farm 1, demand function of good 2 is this, which is produced by Farm 2, and the cost functions are same. It is like this. Suppose Farm 1 moves first and Farm 2 moves second, and find the subgame perfectness. So, this is a standard problem, and you can solve this. Profit of Farm 1 is 12 P1, this is 0.5 P2, P1 C, it is this, and profit of Farm 2 . So, there it is a negative sign. So, it means the products are, if the price increases, then demand goes down, or if P2 increases, demand for good 1 goes down. So, it means goods are complementary in nature. Is this? So, we will use backward induction. First solve this with respect to P2, and we will get is equal to 0, first order condition. So, the reaction function of Farm 2 is it is this. Now, you plug in this in the profit function of Farm 1. Take this. So, this is, you can write 24 minus 2 P1 is 6. It is this, and you differentiate this with respect to P1, you will get what? So, if you take the derivative of this part first, we will get this, and the first order condition will give that this is equal to 0. So, we get this part is equal to 18 plus it is 2 4.50 P1, cost is 2.75. It will be negative. So, it will be negative with positive. So, this term is actually negative. Okay. So, this is equal to 0. So, 18 minus, it's, I think there is some problem here. This term is going to be plus, and this is, so it is plus 2.7. So, it will be, this part is 2.5 plus 2.25, there is minus 0.5. So, it will be 1.75C with this, and this will be so this is the price, and you plug in this price in this reaction function and you will get P2 is equal to 12 plus C minus 0.5 this 18 plus 1. Okay. So, we get this in the stage 2 and this in the stage 1. So, these are the subgame perfect Nash equilibrium prices in this price competition. Okay.